Hello, this is Stephen Kensley, author of Docker in Action. We're here today to talk about securing data in an AWS S3 bucket. And it might not seem like those two things go together, but I spent the last 5 years helping people migrate into AWS securely and protect data there. So that was a lot of DevOps, a lot of cloud work. And Docker containers are great for helping you protect your data, protect your compute, and protect, like, say, your file system that the application is accessing and so forth. Make sure that the right bits get out onto the platform. But one of the hardest problems of migrating to AWS is really getting a handle on the security policies that protect data. So today, that's what we're going to do, and I'll just show you, what we're going to do is we're going to start with kind of describing some of the problems in protecting data and why it's so hard. Explore that a little bit. And then we're going to improve some policies that you're going to find with a default S3 bucket configuration, as well as see and really understand why some of the managed policies and things that get copied off of blog posts maybe aren't that great for your security. And use some tools to understand those and then verify that they're improved, whether that's a least privilege policy or something else. So and that's basically the description, helping people understand and improve security policies to protect data in AWS. That's literally what I do these days. So that's why I wanted to share this with Manning's viewers. So with that, let's take a look. So we're just going to start off with why this matters, and then go into how AWS access policies are evaluated, some common mistakes, and then demo how to implement a least privilege access policy and protect data in S3 with a least privilege policy. So if you have questions, I'd love to try to answer them. Pop those into the chat, and or if you have a problem that you want to try to work through, I'm happy to try to do that. Though with security policies, as we're going to find out, they're often pretty nuanced, and I may not be able to answer every question, but I'd like to give it a shot. And you can always find me on Twitter, and we can continue the conversation there. So cool. Let's rock and roll. Let's see. So I just want to start with a little motivating bit. Why does this matter? Something so this data is out of the Scientia Information Risk Analysis Report, and basically a study that was released earlier this year that covers the last I want to say 10 or 15 years of security breaches, and almost a quarter of Fortune 1000 firms are breached annually, and they're often breached multiple times a year. And the typical loss, the median, varies by industry, but it also mostly varies by size of organization. So the typical loss is $350,000 to $1 million per event. But you have also some very large events where an organization might be impacted at the $5 to $95 million level. And that's mostly the size of that loss is really driven by the size of the organization and its revenue. So you can you can, the bigger your organization is, like the more important or the more revenue your organization processes, the more important and impactful this kind of practice is. So, and it can easily run in $100 million. And like that's actually what the Capital One folks estimated their breach is going to cost. Like when they announced it, they actually put it at 100 million to 150 million. This past week, they actually were fined $80 million. So they're definitely gonna hit that that number. Um, let's see, but what to do about it? Like, why are we here? Oops, sorry about that. Wrong window. So this is like it's hard. Like this is a little diagram I've made of like the evaluation process of a policy and an action. So say you have an IAM role or an IAM user, and what that is like in your AWS account, or a lot of people have many AWS accounts. You'll have users that you create in AWS, or a role that you create in AWS, and that's what your application runs as, and that's what your administrators or application engineers may be accessing AWS with. And when they issue an action or an API request, they say access and get data out of a bucket, then the IAM policies associated with and attached to that principle, they might say, yes, this principle is allowed to access that data, or they might not say anything at all, or it might say no, it might deny the access explicitly. In either case, unless there's a deny, if it's allowed or not specified, then the request will proceed along to S3, wherein the bucket policy, we call it, or the resource policy. There's a general concept of a resource policy in AWS where you can put security controls directly at the resource level. And the AWS security engine will take that resource policy and incorporate it into the decision-making process. And that decision may be to allow or deny the get object request. And then there may be service-specific things like built-in, like service-specific security controls, like access control lists that may permit or deny access to like a particular file in S3. And so now we've got at least two policy types. We've got all these different conditions that might be getting evaluated, and there's there's another layer that these ACLs, and like this is really hard for folks, and so you can often get in a situation where you may have accidentally provisioned or allowed access that you didn't even realize was happening. So we're gonna see how to explore that today, and it turns out like one of the short stories here is that resource policies are, I think they're critical to least privilege, and so if you want to sorry, I was a little confused. I was looking at the Twitch website and the Manning channel. So, and if you actually want to implement type privileges, basically you're gonna want to limit access with a resource policy. And the trouble is that it's not so common, and so you can run into situations where S3 buckets don't have a resource policy by default, and that means that whatever IAM decided, access is going to go through. And unfortunately, there's really a lot of pretty pervasive and open privileges granted often by managed policies from AWS, basically allow like get object against every resource in the account. So we're gonna see we're gonna dig into that into a bit of detail today and see how to resolve it. And what I just want to point out here is that there's really two keys to implementing a least privileged resource policy. One is an allow for whomever, whichever principals you want to have access to the data, and then basically you need to deny everyone else. And this deny is what everyone is missing. So, we're like 12 minutes into this. Feel free to like take a screenshot or whatever. Like this is kind of like the answer, like, or at least the raw bits of if you want to really restrict and implement least privilege within your AWS accounts, that for protecting data in S3, you'll want a resource policy that allows certain the principals you want to access the data and then denies everyone else. And that's the simplest way for sure to get that done. So we'll back up just a bit and let's go through. This is what policy evaluation looks like in AWS, and this is actually directly from the docs. I copied it in here to make it a little bigger. But everyone starts off with a deny, and then there's 5 different kinds of policy that come in to play. There's service control policy. Those are actually policies that exist outside of an account, and they can deny particular actions or particular services. So an API action is something like S3 get object or EC2 create instance. And so a service control policy, those are useful for doing things like implementing like high level governance and like enterprise level governance features. Like saying we only permit use of HIPAA compliant services, or you have to always use encryption when provisioning a particular kind of resource, something like that. And then the next step in evaluating whether an action is permitted is the resource policy associated with the resource will be checked. And so this is actually backwards or the reverse of the flowchart that I made, because I was thinking in terms of going forward from the principle, but it works either way. And what the resource policy can do is it can either allow access or it can deny access. And if the resource policy allows it, then great, the principal gets in, unless there's an explicit deny, which since this is the first one, it hasn't been denied. Then there are some policies called IAM permissions, boundaries, and session policies. These can again narrow down what is allowed, and the last thing is identity policies, or what we usually refer to as an IAM policy. And that's where, you have a policy attached to the principal, the IAM user or role, and they can either be allowed to perform an action, and they may be allowed to perform it on all resources or specific resources, or, there's all kinds of policy conditions that you can put in. That's about what I want to communicate here. That the key is, or the big takeaway here is, this is a pretty complicated process, especially when you think about the number of actions that are available, the number and how like some and how and just how many resources there are. So there's a lot of doing like fine-grained access control is really hard. And the thing to keep in mind is that there's two places where an allow might happen. An allow might happen in the resource policy or the identity policy. And so common mistakes are that you might have a policy that uses a wildcard and just permits everything, or like a lot of actions, like S3 get star. And that might grant like more actions to, like, say, read data. If you have an application that only needs to read data, there's no sense in giving it like write data access to, say, S3. Now, there's another issue in that people often grant unconditional access to resources. So let me back up and show you the structure of a policy. So the first thing I was talking about is these actions that you can, you can either allow or deny. That's the basic effect, choices with effect. Action means that you're going to grant either something like S3 star or S3 get star or S3 get object. Those are the actions. These are API actions, or an API method. You can think about it that way. And then your policy will say, like, what resources are you allowed, or is the principal allowed to invoke that action on? And commonly, this is star, which means all of the resources of that type, so all of the buckets in S3, let's say. Now, of course, you can specify a particular bucket or even a particular path underneath the bucket. What goes underneath here is an ARN, an Amazon resource number, or a list of ARNs. So you can use stars in there. See, they don't put an example here. We're going to see an example in just a bit. But one of the challenging parts here is that writing security policies takes quite a bit of time and thinking. And so a lot of folks will often use AWS IAM managed policies. So these are, the policies like administrator access or read-only access, or power user. And those always, I want to say, use a star for a resource condition. And if you think about it, like, they have to. Like, AWS is publishing those policies for everyone in the world to use, and they don't know what's inside your account. And they don't, they're not prescriptive about, say, a tagging scheme or something where you're going to limit some access via tags or something like that. So basically, if you're using AWS IAM managed policies, they're not going to have resource conditions on them in the general case, and they're probably going to allow a whole bunch of API actions that you may not need. So anyway, those are the common mistakes, and maybe you're feeling a little sad right now. This doesn't sound good. Even smart people are going to be really challenged by all this. So why don't we kind of go through an example of getting to least privilege. And I just want to remind you, if you have some questions or you want to like explore something in particular, happy to do that. So what we're going to do in this little exercise is secure an S3 bucket. Oh, and from its default config. And I just want to share that this is actually available. I'll put this in the chat. It's actually available on GitHub if you want to like recreate this and follow along. So you know you can take a shot at this later, and if you have questions, feel free to hit me up on Twitter. I'm at skensley, or my handle is skensley. But you know this is really hard. So let's kind of go through and get into some of the details. So we're going to do this in a few steps. We're first going to take a look at like what the defaults get you, and I'm just going to go back here. Clear. Let's see. Maybe grab AWS. All right. I'm just going to start a new session using my handy dandy AWS Vault tool, which is best way or one of the best ways to manage AWS API keys locally, because it stores those secrets in your keychain. And what I just did here is I launched a shell with some nice access. I'm going to you can see we've got some credentials in here. These are short-term credentials, so I'm not too concerned here. All right. So I previously deployed an S3 bucket, and we can AWS S3 LS, and you can look at or actually we can show the Terraform code right now. So it's really simple. We created, and you don't need to use Terraform. This doesn't have much to do with Terraform at all. I just used Terraform to spin up some resources. Created two buckets, a restricted bucket that we want to eventually have restricted access to. It's got like important sensitive data into it. And there's a logs bucket. And then there's a role, an application role, and a firewall role, and both were originally provisioned with Amazon S3 full access. So I'm just going to show you, let's see, Terraform, apply, auto approve. We'll just make sure that this is like up to date. All right, so take a few seconds, hopefully. All right, so yeah, didn't actually change anything because I had kind of prepared things beforehand. And the names of our buckets are sensitive data-F8 and logs-F8. So let's see. What I want to do is I am going to come over here. I'm actually going to log in again. Get a fresh token. All right. So, okay, we have a logs and a sensitive data bucket. Sensitive data. Let's go check out. Oops. The bucket policy. Oops. Well, let's delete that. Should have been deleted. Okay, so there's no bucket policy. That's good. All right. And we have a couple files here. Now, I had previously uploaded these, and so there's basically no extra configs other than like it's basically what you would get by provisioning a bucket using Terraform. That's all. And so, you know, we get some things that are important. Like, first off, I want to point out that external access to the data inside the bucket is denied by default. Okay, you know, so what I was showing here is here's the URL to that object. If I, you know, even if I, you know, I'm already authenticated into AWS via my IAM user, but and I don't have access, and neither do I have access if I am just public, or sorry, if I'm anonymous and coming in from the public web. So that's good. But let's focus on like what does the internal access for IAM look like. So what I want to do is I want to introduce you to a tool that I know and love very well. We'll go to the IAM dashboard and all right. So here's our firewall role and our application role. So pull up the firewall and go ahead and remove that policy for a second. Okay. All right. So here's that Amazon S3 full access policy. And you know, this is a managed policy, and it's very simple. This comes from AWS, and it allows someone to use anything in S3. And you know, that's a way a lot of folks, you know, and you can imagine that somebody might actually deploy a firewall this way. There are breaches that happen where something, you know, policy probably similar to that has happened, and that that role can then be used to exfiltrate data. So like let's kind of see how that might happen. Not so much the exploit of the firewall application itself, but like once it has it, once an attacker is on that firewall machine or has some credentials for that firewall role, let's see what can happen. And so I'm going to show you a tool now that is let me pop up a new tab here called the IAM Policy Simulator. And so go to here and let's see if the firewall role can access our bucket. So what I'm going to do here is I've selected the firewall role over on the left, and you'll see that it brought up a list of policies that are attached. And what we're going to do is we're going to actually simulate access, like simulating getting data and so forth from our bucket. And we can do that with get object. So the way the simulator works, let me back up just a second, is you can select the service and the API actions that you want to test access with. And so, okay, so we can run a simulation, and this is simulating access to star or like essentially any resource. And this says that the firewall role can access any or can call get object on any resource in IAM, and that makes sense because that's precisely what its IAM policy said it could do. So it's got Amazon's S3 full access, and that allows S3 star. So we can do things like we can add another action here too. Let's do put object. Okay. All right. I'll run the simulation. Okay. Yep. And one really neat thing about the simulator is it will show the statement that actually permitted access or allowed access. and it says, aha, like this is the statement. This is the actual statement in the IAM policy that permitted it, permitted the action. And that's great because figuring out what statement in this like sea of policies either resulted in the allow or deny can be very difficult. So then we can take it a step further and we can check, that this is what you see here is the answer to the question of can the firewall role call get object sort of in the general case? Well, we can also have it account for resource policies. And so when we run the simulation again with the resource policy in play, you can see down here, and I apologize, the view is in the simulator is a little wonky. But now the simulation is being run with the resource policy associated with a sensitive data bucket in play, and it's still allowed, and which is actually what we expect because there's no resource policy. And so there's, just to verify here, we're in sensitive data, there's no resource policy, just reload it to be sure. Okay, great. So our firewall role, if someone gets credentials for it, it can definitely retrieve our sensitive data, which we don't want. So let's solve that problem, or let's try to solve it. So what I want to show you, let's see, there's two ways we can do it. We got plenty, we're rocking and rolling here. The way I usually do this is oh yeah, bucket ACLS. Well, we're going to skip over bucket ACLS for a second. We can maybe come back to them. What I want to recommend you do is use AWS's block public access features, and know that basically they only prevent access cross-account and to the bucket at large. They don't actually protect like individual. You can still manage the ACLS on individual objects in the bucket. So we'll come back to that maybe later. So let's limit, but let's go back to the firewall role and limit access via IAM directly. So we can solve the problem. You may have caught earlier, I had a log writer policy. So let's go to IAM. Say that firewall role needs to be able to write logs to S3. So what we could do is we could have an IAM policy that basically just allows put object and two particular resources. So I've put the logs F8 bucket here, so which is presumably what they want to be able to write to. But they don't need to be able to read or put objects into the sensitive data bucket. So let's go back and let's attach that policy to the role. We'll remove Amazon S3 full access. And there are commands in the GitHub bucket. I'm kind of doing this in the console right now. There's commands in the GitHub bucket that you can follow if you want to reproduce this just with the CLI. So let's attach a policy. We'll do log writer. Okay, I'll attach. Okay, let's come back to the IAM policy simulator, and I am going to reload this whole page because the IAM policy simulator caches a bunch of state. So it's important to when you make a policy change, either in IAM or on a resource policy, or like you add a resource policy to a bucket, that you basically reload because it's 2020 and that's still a problem. Let's see. So let's see if those two actions are still accessible. Put object. Okay. All right, so we're going to do that again. And let's grab that ARN. Okay, run the simulation. Okay, so it's denied. That's pretty cool. That's great. So that's one way to prevent the firewall role from being able to access the sensitive data bucket. And we can change this to be logs. And this, let's see. Oh, okay. Didn't change this one, I guess. All right, run the simulation. Okay, great. So now we've verified that the firewall application will still work. Like it only needed to be able to put logs into the bucket, didn't need to be able to get logs out of the bucket. So this is fine. This is good. Okay, let's go on, or like let's do something else. Now the problem is that if we reattach that S3 full access, policy, there's bound to be a whole bunch of, or even read only. Let's say someone along the way comes along and adds a read only policy to the firewall. Now, to reload this, I guess. Okay. S3, get object, and all right. So now we're back in the situation where, and this could be, any role in the account, with one of those managed policies with a wildcard access resource condition permitting access. Like basically anybody's going to be able to have access to that sensitive data. So let's move forward to resource policies, because it's kind of the only way to be sure. Like we actually need to narrow the problem space from every principle and getting every policy for every principle right, to let's shift to the few or most important data sources, and let's start by protecting them with resource policies. You might consider this as defense in depth or whatever, but honestly, it feels like the place that people should be starting at this point. We need to clean up that kitchen sink, because this is a choke point, that resource policy. So you have, because there's only a few resources that are really important. So what we're going to do is let's take a look at a policy that we might think is going to be useful. So what we essentially want to do is we only want the application to have access to the sensitive data. So a lot of people are going to start with something like this. They're going to think oh, this is really great. And we're going to limit our access by, and we have a very narrow policy. This is going to allow access to this application role. And it's going to give them S3 star. Let's say they have full control, and they're going to get it just for this bucket and the resources inside it. Now they can kind of do anything, and that's maybe narrower than is preferred, but that's fine. So let's come to the command line, and we're going to put a bucket policy onto sensitive data F8. I'm going to use that policy I was just showing you, and we'll run it. Let's go back to here, to our sensitive data bucket, and we'll look at the bucket policy. Here it is. That's great. Okay. All right, let's go to ye old policy simulator. And we're going to reload because the caching problem I was talking about earlier. And I'm going to leave the firewall role with both that log writer and S3 read-only access policy attached. And let's do S3 service, get object, and put object. All right. Okay. And we will, that's not what I want. Oops. All right. Okay, so there's the same. We're going to test get object and put object for the sensitive data for the firewall role. So this, what we're hoping for is that both of these are denied. Except they're not. And the reason is that, okay, well, actually, we can look in the simulator. The simulator will tell us which statement. So the get object was permitted by S3 read-only access. So there's the put object was denied because it was an implicit deny. There's no statement in a policy here that would permit the firewall role to put into the sensitive data bucket. So, log writer gives the ability to put into the logs bucket, but doesn't give the permission to put into the sensitive data bucket, which is good. Like, we wouldn't want them to be able to overwrite data, but the problem is that they can exfiltrate data using get object. So we need to fix that. And you might be wondering why that happened. Well, the problem is that managed policy granted a bunch of permissions to get data from all the S3 buckets in the account, and we need to limit that. So let's take a look at how to do that. What we need is this deny everyone else statement. So so here's another policy, and this exists in the exercise bucket on Git, or the exercise repository on GitHub. But this is that same allow statement, and now we need to add a deny everyone else. So let's go ahead and paste this in here. So let's just walk through this. This is going to deny everyone else access. It's going to be doing that by, it's going to match all principals. It's going to cover S3 star actions. It's going to cover this bucket and everything in it. The everything in it is the /star here at the end. That covers all the keys. And then it's going to carve out an exception for the application role, which should have access. We want them to have access. And the role that I'm using. And this is important. You don't want to lock yourself out as an administrator, or whatever your control plane is. In this case, I'm doing the demo, and I'm the control plane, or this role that I'm using is the control plane. But I need to be able to administer things for this bucket. So this is kind of a simple case, or a simple policy. But basically, the trick is we're going to deny everyone access, and then we're going to accept a couple principles from that statement. So go ahead and save that. Okay, so it did. I'll just reload this to make sure I believe it's there. Okay. Go back to the simulator. It will reload because of the caching I was talking about, caching problem I was talking about. Get object, put object. All right, and we'll set the resource to evaluate against. And now the simulator has prompted us for something new. It looked at the policy. It knows there's a sensitive data resource policy here. And so it wants to prompt us for the ARN that we're testing access for. So, that ARN, let me scroll things back into place, is firewall. Okay. And these are now both denied. That's great. Hooray. And now we can see the most important thing here is that the get object, that statement, the simulator tells us that the resource policy denied it. So this is literally the answer, or a demonstration of the answer to the $100 million or dollar question of how do I keep my very sensitive data safe from exfiltration by a firewall role or an unrelated role. So I just want to go back and show you this policy a little bit. So again, the application is allowed access and everyone else is denied. So let's prove to ourselves, let's prove that the application does actually have access. We'll select application, Amazon, that application role has Amazon S3 full access. And let's go ahead and run this. This might, yeah, let's reload this. That was actually a demonstration of the caching problem. Okay, we're still in the application role. Oh, I guess I didn't change the principal arm, so maybe I can't blame it on caching. S3, get object, put object. All right. Okay. And we'll set the resource to that. Okay. Set the ARN that. Okay. So we're going to test application role with the S3 full access policy. We're going to supply the application's ARN as the principal ARN. We're going to call get object and put object. Okay, that's what we're going to simulate. Okay, boom, let's run it. Great. Now, this is what we expect. The application does indeed have full access, even with that very restrictive policy. And if we ran the simulator for this admin role, we would get a similar result. So, hooray. we just we just implemented a least privilege bucket policy and least privilege access. And the key to the whole scenario is that we're using a resource policy that, yes, it allows some things, and then it basically denies everyone else because you just don't know what else is going on in the account in the general case. Once you get past about two applications or like even one application running in an account, you often don't even know like who has access to what, which is what I specialize and my company specializes in answering that question. And in particular, like what data is accessible by whom. So anyway, takeaways for this stage: you should limit access to sensitive data in S3 buckets using S3 bucket policies, S3 resource policies. And the key to those policies, the very most important thing, is basically to allow what you want. That's cool, but then like the important bit is to deny everything else, and that's what closes off access from everything else that's going on in the account. And it's one place that you can look and audit. Okay, so and now like instead of like a sad pup, maybe you're a little bit more like this one. So, he's still like a friendly Doberman, or she's like a friendly Doberman. But, couple things that you should keep in mind: protecting your data with a narrow AWS security policy is harder than it looks. There are tools that you can use to understand. I think the simulator is the very most important tool that most people have access to, and that you're going to want to encapsulate this knowledge of like how to build least privilege policies and like build that deny everyone else statement. Like you're going to want to do that programmatically with your infrastructure code tool of choice. There's we're not the only ones, but there are companies like K9 that we publish Terraform modules that will do this kind of for you and like generate a least privilege policy. It's really the only, and I mention that because I think it's really the only way to manage this kind of policy and create these policies correctly at scale. So there are some things I've written on this, like that help explain in more detail, like why are good AWS security policies so difficult. It's like a written form of what we walked through at the beginning. And so, feel free to check that out. Feel free to ask me some questions. I'd love to take questions now or like a little bit of a challenge. I'll be around for at least another 5 minutes. We can take this moment to return to block public access. We'll talk about that feature a little bit. So block public access is a feature that Amazon released, I think, late last year. And they definitely got the name right. Everyone wants the capability to block public access. That's really important. We don't want to like accidentally have our stuff getting made public. And you can apply this feature, use this feature with buckets, with access points, and even an entire account or organization. That's really great. Of course, it can be hard to apply like block public access, certainly to an entire organization. Usually somebody needs like a bucket public to host a website, though you can definitely front that with CloudFront instead and and only permit access to CloudFront. So there's kind of an exception for that you can do that. So I think that I'll focus on essentially what on Amazon's own warnings or AWS's own warnings about the block public access feature, which is that it basically enables you to keep people from using access control lists and canned ACLS policies that permit the bucket to be public. The warning is actually the really important warning is really down here in the note. The block public access setting doesn't apply or isn't evaluated for individual objects. So you can have a bucket that, and we can see this actually. I can show you this. You can have an object that is public using ACLS inside of a bucket that is not public. And for some people, that's a legit feature. So let's see. Wait, no, I don't want to do that. So this, we can go ahead and I'll show you how this works. So this is, again, this is the sensitive data bucket. We'll go ahead and block all public access. And what it's going to do is going to block access through ACLS, supposedly. And it's going to block access with cross-account IM policy, which is good. Like, you can leak data through cross-account IM relationships. That's good. All right. So let's we'll type confirm. Okay. Now you would think like, oh, I can't make an object public. So we'll make the file2 public here in a second. Okay. So this is denied. This access is denied right now. That's what we kind of expect. Let's make this thing everyone. We'll give everyone read. No, let's do read object. Okay. Okay. So now you get a little warning in the dialog. I mean, that's cool. But now when we launch this, did it not take effect? That's maybe I did. Save. Oh, I guess actually the feature is working. Actually, that is working. That's good. I was thinking of this from another direction. If you have objects, missions, any access controls. Actually, this is better than I thought. So I have. Let me reread those docs. Okay. Actually, that does lock it down. That's good. I must have mistested that previously. But yeah, we'll just leave that locked. So that is actually a great way um, to lock down and clean up any ACLs that you may have floating around in your account too. Okay. So, all right, I'm going to save this, confirm. Let me show you what it looks like when, oops, permissions. Hmm. Maybe that's what I was needing to do. Well, I'm like off the rails, sorry. Um, this is all off. I don't know what I've done. This is all off. Read object, yeah, everyone has read. Well, anyway, I guess that's what I get for going off the script. I'm not going to debug it live. Again, protecting your data in AWS with narrow security policies can be harder than it looks. There are tools that help you understand the actual effects of your policies, and you can save time by basically encapsulating this stuff, those rules in infrastructure as code, CloudFormation, Terraform, Pulumi, whatever, and like reuse that stuff because the patterns are the same, and like when you want to like give access or prevent access. So, code those up and like reuse a solution because writing the policies by hand can be very painful and time consuming. If you have any questions, feel free to hit me up on Twitter at skensley, or you can even shoot me an email if you like at hello@k9security.io. But let's see, the code that was used for this exercise, you can find it in some commands in like kind of a challenge form. It's available in the K9 repo or K9 org on GitHub. It's called exercise secure in S3 bucket. And happy to connect with you and answer questions or help you out. If anybody has anything, happy to answer it now. Otherwise, I am going to bid you adieu. Thank you for joining. I'll talk to you later.